I think there's a valid concern that maybe we're giving machines too much power. Or maybe we don't want machines to be self-aware. In my opinion, everybody should understand that this technology is around the corner. Your children, your grandchildren can be living in a world where there are machines that are on par and possibly exceed human self-awareness. And what does that mean? We'll have to figure that out. Inside his Creative Machines lab, Hod Lipson and his students are taking the first steps towards sentient machines. Scattered on shelves and tucked into cubicles, their robot menagerie is probing the biggest philosophical questions that face robotics and AI today. As these deceivingly simple machines squirm and babble, they're crawling towards a future where robots can autonomously adapt to and understand their surroundings, embarking on a quest to unlock artificial consciousness. We've been making huge advances in robotics for decades, but engineers investigating these philosophical questions has not always been a widely supported pursuit. For many years, this whole area of consciousness, self-awareness, sentience, emotions was taboo. Academia tended to stay away from these grand claims, but I think now we are at a turning point in history of AI where we can suddenly do things that were thought impossible just 5 years ago. We humans cannot babysit all these incredibly sophisticated systems that we created. We need to gift them with this ability to see themselves. To do that, Hod's lab is taking a unique approach. Instead of trying to understand and replicate something as complicated as human consciousness, they're looking into something a little simpler: the ability to imagine yourself or self-simulate. So the big question is, what is self-awareness, right? We have a very simple definition that self-awareness is nothing but the ability to self-simulate. The dog might be able to simulate itself into the afternoon, but if it can see itself into the future, maybe it can see itself having its next meal. Now, if you can simulate yourself, you can imagine yourself into the future, you're self-aware. With that definition, we can build it into machines. The first idea to use the arm really came about because arms are one of the most common types of robots, and they're also fairly simple. We have the robot start by flailing around. We call this motor babbling. It just moves, it's just a child in the crib. After moving for one day, it collected enough information about its body to understand the dynamics of its motion, how when it moves, what's going to happen to its position and the ability to move in the future. The team fed all of that data into a deep learning model, allowing the robot to predict its next position based on its previous one. Essentially, it's using the model it created to imagine its own motion. From there, we were able to use this model to plan how to effectively accomplish tasks. In this case, the robot is sort of going through a variety of different actions that it could attempt to make, testing them on the self model, and then executing the one which will bring it closest to its goal state. So in this case, the goal state is right rooted right now on the ball, and then it will move as its next goal state to the cup, where it will then drop it. It's a little bit tricky because you look at this robotic arm and you'll see it doing its task and you'll think, oh, I could probably program this arm to do this task by myself. It's not a big deal, but you have to remember, not only did the robot learn to do this by itself, but it's particularly important, it learned inside a simulation that it created. To demonstrate the transferability, we made the arm write us a message. We told it to write hi, and it wrote hi. With no additional training, no additional information needed, we just used our self-model and wrote up a new objective for it, and it successfully executed. So we call that zero-shot learning. We humans are terrific at doing that thing. I can show you a tree you've never climbed before. You look at it, you think a little bit, and bam, you climb the tree, and the same thing happens with a robot. The next steps for us are really working towards bigger and more complicated robots. Walking robots are much more of a dynamic and complex system, and as such we're actually going to start developing on that robot over there. So it will do the motor babbling, and we hope that we can learn a variety of tasks on that, the same way that we did on the arm robot. We believe that while this is a small, simple start, by progressively improving the model and the bodies and the capacity of these robots, we can push the border between robot and human to become smaller and smaller with each additional iteration. Every automated system would benefit from being self-aware. Everything from driverless cars to airplanes to smart cities to traffic lights. Imagine that your factory is operating, is creating, I don't know what, solar panels, and it understands if things are working well. It could foresee a problem on the horizon, and it's going to take measures to compensate or recover from that. All that is incredibly useful no matter what you're doing. But regardless of the benefits, the idea of self-aware machines will inevitably raise concerns. Experts from the likes of Stephen Hawking to Elon Musk have warned about the dangers of advancing AI, cautioning against a future where it progresses to a point beyond human control. To me, it's very similar to discovery of fire. They can do a lot of bad things with fire, but there's no doubt that fire is an incredible technology, changed our civilizations forever, so we can try to quench it and say, okay, we're not touching this. But I think a much smarter thing to do is to say, how can we try to use this technology for good and sort of understand its pitfalls